The second type of thematic map that you need to be able to make and to distinguish between is a quantitative map. So we looked at qualitative or categorical data prior to this, and now we're going to look at numeric or quantitative data. So if you reflect back, when we were looking at DEMs and creating school locations and hillshades, we were really making types of reference maps. We really didn't have a theme. We weren't looking at the distribution, other than you could kind of determine that, but that wasn't the focus of the map. So we're going to really work on the distribution of geographic phenomena with thematic maps. We're going to look, you can be looking at where is rainfall high and low, where's temperature change. We can look at the elevation again. So elevation contours can focus between thematic and reference. They're kind of a bridge between those two types of data. So we looked at zoning, we looked at vegetation, but we mapped the quantity or the type. We really didn't do a lot about mapping the values, the height of trees or the density or the canopy cover or the velocity of rivers, and that would be the difference with quantitative mapping. So we looked at types of things with qualitative or categorical. Where were the schools? We looked at, those points were schools. We looked at, we can also evaluate the type of soil. So we would use the nominal data, the name of the soil, in order to map where that soil type is. We could distinguish between types of roads if that's in the attribute table, if it gives the name of the road type. With quantitative mapping, we're going to be looking at the magnitude, some kind of number, not just where are the elementary schools, but maybe the number of students per school, not just the type of soil, but maybe the depth of the soil layers. And with roads, you could look at maybe number of accidents or the width of roads. All of those would be a magnitude value. We won't go over this too much this term, but another distinction between geographic data is whether it's continuous data or whether it's discrete data. And a lot of vector data is representing primarily discrete data, and often raster data when we're looking at elevation or we're looking at temperature, we're looking at continuous data. So continuous data would be a data value that is graded along the surface. There's no hard edge to that. So with discrete, if you think about roads, houses, rivers, buildings, there's not a gradual border zone between a house and a river. You can figure out if you're on the house. Now the river, we could talk about wetlands and swamps, but if we're thinking more in terms of the way the data appears on the map, air pressure would have a continuous surface, elevation would have a continuous surface, and the other data would, like vector type data, would be discrete. So if I'm looking at slope, I'm kind of evaluating that all areas have a slope, whether it's a negative or a flat or a high slope. They all have a slope. You really wouldn't say there is no slope. Literally, a value of 0 is data. But if I'm looking at the residences on these slopes, then the residence would be discontinuous or discrete data. They would have a location. I can look at these road lines here. Each of those would be discrete. So when we're looking at thematic maps, we can think about data that is one variable or one theme, or multivariable, multivariate, more than one theme. So we could look at the location of campgrounds, as just one data value. So you could name all of the, whether they're tent sites or camper sites or yurts, or you could look at a multivariate qualitative. So where you're showing the location of schools and the location of known pedophiles. So you have two variables on that. Or you're going to show maybe the location of yurts and the location of nice hiking trails. So you've got two different data layers showing two different types of data or features, themes on one map. With quantitative, a single data layer might just show the number of visitors for the campsites, and then it also might show how used trails are. So you could have both of those to be multivariate. So this is just a nice qualitative map showing the location of violent crimes in 2004. But you can see if I turn that into a quantitative map showing the number of violent crimes. So this just shows that there was a city that had a violent crime. It's not a very useful map, really. But when I take that and I'm showing the magnitude, as in the number of violent crimes per city using a graduated symbol, I've got a little more information about the map or about the data. So when I want to show quantitative differences, I need to quantify my variables in some ways. So I could use sizes of circles, I could use intensity of color, or I could use intensity of pattern. So very typically for a point symbol like the crimes, you can use graduated circles that get larger. I could have also colored those circles, which I think I actually did, from light blue to dark blue as we went down the number of violent crimes. Lines could be shown by the width of the line. It could be shown again by the color. If I'm trying to show a quantitative or a magnitude of difference. Area, we looked at cartograms on the very first day of class, so I could expand a polygon, say school building by height. If I wanted to show the number of kids in that school building, I could also show it by just different patterns. And historically, when cartographers would make maps with pen and ink, these ideas of pattern were very common, showing different texture as your magnitude increased. When we talked about qualitative mapping, we talked about data that was primarily text, so nominal data or a category, or maybe even data that had a key. So it might be numbers 1 through 4, but those stood for some type of data, where oak is a 1 and pine is a 2. With quantitative data, we're looking at the scale of measurement of the number as ordinal, interval, or ratio. And ordinal can kind of go back and forth between the two types, but we're going to put it here in quantitative data types. So ratio data is data that has a meaningful scale, where 0 means the absence of the phenomena. So if I had a field that was let's say a number of crimes in a city, if there were no crimes, the value of 0 would make sense. It would actually mean no data or no crimes. It doesn't mean no data, it just means no crimes. Meaningful numbers for ratio variables means that I can do some mathematics, and the mathematics makes sense. So if I have a city where the average age is 57 and another city where the average age is 47, I've got a 10-year difference, and that's a number that I can talk about, or that I could map and make sense. Population, a city with 1,000 or a city with 100, being able to say, oh, you have 10 times more people in one city, or you can have a city of none. Drunk driving arrests. Again, we've got a magnitude and that number makes sense. Rainfall in Oregon makes sense. So ratio variables are numbers where it's an actual number where the zero means absence of the phenomena. And one way to remember that is the word ratio has a zero in it. And so the zero is important to spell the word ratio. And I make that point because interval data is very confusing for people. Interval data has a zero, but the zero is an arbitrary starting point. So when you think about temperature, a temperature of zero does not mean that there is no temperature. It just, that's the starting point on the Fahrenheit scale. Unless you're talking about, Kelvin. I think Kelvin has, I'm going to have to look it up. Hold on. Yes, Kelvin temperature would have an absolute zero, but we're not going to go there. So elevation, zero does not mean absence of elevation. It just means that you're at the starting point that somebody arbitrarily set as sea level. And you can kind of do math on these numbers, but it doesn't mean that a temperature of 32 or 30 is 30 times more than a temperature of 1. It just doesn't make sense. But you can look at rainfall. A rainfall of 0 means there was no rainfall. So find a way to kind of distinguish those two data types from one another. And there's a link here that, let's hope that still works. I haven't checked that in a while. That has a book of the government mapping symbols that are used on a lot of topographic and other kinds of maps, and it's really very important or very useful. Oh, well, it looks like something's happening here. Let's let that load up. I tell you, I am in my office and the internet is ridiculously slow today. Oh well, we're going to give up on that, and if it doesn't work, I'll try to find a new link to add here. So when you're mapping ratio data, you really want to think about quantitative maps and Choropleth maps. And I have ordinal crossed out because this is kind of the gray area, which I don't really mean gray, but ordinal, if I have an intensity of 1, 2, and 3, I could use a Choropleth map for that as well. So a Choropleth map would have color intensity varying with the map intensity. And so here is a nice example of a Choropleth map where the darker color means the higher divorce rate and the lighter color is the lower divorce rate. And so you want to make sure when you start out with your map that you look at your attribute table, you know what kind of data you're mapping, and then whether you're mapping categorical data or whether you're mapping quantitative data, and then being able to choose a right color ramp for that. The other choice you have in ArcGIS is mapping the number of classes in your data, or how you want your data to group. And in ArcGIS, ArcGIS defaults when you're mapping ratio data to what's called Jenks natural breaks. And Jenks natural breaks looks at data and it looks for gaps in the data, and then it sets those breaks so that you don't have a misrepresentation of the data. So let me pull up ArcGIS here, and I'm going to add some data that's on my totally full flash drive here, or not. Let's see. Nope, I'm going to have to make a connection to my flash drive. And sometimes it's just easier to connect to the root drive, and then I can go in and navigate from here. It's a little more clicking, but sometimes if you connect too deep, then you're kind of stuck. Excuse me. Okay, so I'm going to go into some price data. This is the data that we'll use in the next term. And I want to look at, let's just add some US data. And this is a new feature that we haven't talked about called a geodatabase. And it's a more modern data feature. And I'm going to open that. Boy, things are slow. And I'm just going to add county data. And when I add that data, it's drawn originally as if it were just a feature just drawing the location. It doesn't try to pick one field. So I'm going to now go in and take a look at my attribute fields, or my attribute table. Okay, so I have got a categorical data saying the name of a county, the state name. I've got some state called federal identification numbers, county federal identification numbers. I've got the population of the county, so that's ratio data. Population per square mile is ratio data. This is the number of Hispanic or Hawaiians. So I've got a lot of data here. So I'm just going to pick an attribute to map. So I'm going to go into properties. Or not. And I'm going to just wait and wait. And I'm going to go to symbols. And you can see that this is being mapped originally as just a single symbol, just mapping the location. If I wanted to map categories, I'd have to go see if there was any categorical data, and there really isn't in this data set. Everything here is some kind of either nominal or ratio data. So I'm going to go to quantities. And I want to map, let's just map the ages 5 through 17. So this is the number of classes, and I could say I want 15 classes, so I'm going to map that. But it's really difficult to see the difference between that many colors. So I'm going to go back, and I'm just going to map 5 to 7 is a pretty good number of classes. So now when I do that, I can see a little bit of difference in those colors. That may not be the best color scheme to use. And so I can even go in here now and change some of these myself, make them a little bit darker. I have some flexibility, although I don't think that's all that helpful. So if I go back to the properties, and I look at classify, it's going to show me that there are very few counties that have really low numbers of children, and it's using a natural breaks here. So I have some counties that have a lot of children, and then a lot of counties that don't have very many children in them at all. So let's see, this is between 3 and 3,000 or 38,000. So if I look at that, children, yeah, there's 7,000 children here. So this is natural breaks, which really gives me a better perception of the way the data is distributed. So it's a very uneven distribution. If I were to look at gender, so let's look at the does it say males or females? Ooh, median age of females, medium age. Oh, where's my just? Oh, I thought I had. Let's look at males. So really, in the U.S., we have a pretty even distribution of males and females. It's a little spread out. or it's the even numbers actually. So so that's the natural breaks, which is the default. And unless you are a really great statistician, you kind of want to stay with the default. But I'm going to now say I want this to be equal interval. Actually, I'm going to make another copy of this. Let me just add that. I'm just going to copy and paste that in here. Okay, so this one is natural breaks, and I'm going to have this one default to equal interval. And what you can see how that spread that out, and in reality there aren't very many populations in these smaller groups, and that really changes my map. I don't see any distinguishing differences. So it took those areas of very high numbers of males and spread them out evenly throughout the country. And so it's a very distorted kind of mapping method. So this natural breaks really looks at that uneven distribution and tries to group things so that you have a better mapping perspective. Equal interval was the second example, and that takes the data and divides it into the number of data values regardless of what's actually being shown on the surface. So let's say my data, my number of children in infants born, I don't know, I'm making this up, ranges from 50 to the smallest number of infants born in a county to 1,500 to the largest number of infants born in a county. And let's say I want to group that into 4 groups or 4 classes. I'm going to say classes because that's what the thing. So I'm going to take I don't know why that's like that. Hold on, we have to fix this. No, it's right. I had to look at it again. So the range is from 500 to 1,500. So there are 1,000 values because I don't start at 0, I start at 500. So I take the 1,000 and I want 4 classes. So that means there has to be 250 in each class. So my first data value starts at 500 to 750. My next one probably legitimately 750 to 1,000 and on up. The equal range or equal interval data is really easy for people to understand, but as you could see on my ArcGIS map, equal interval shows very little differentiation in the country. So let's go back and put this, instead of looking at males this time, let's just look at population. Total population. Let's look at population 2010. Let's turn that on. So you see some differentiation here, and you begin to see how things spread out. Let's change this one to population 2010. And if I turn that off, oh wait, I have to go back to equal interval because it defaulted to natural breaks. You can see how there are very little data points showing up in these lower bins. And so if I turn this off, again, I'm not able to see the differences. So let your data default unless you look at your data and you have a histogram that's equal. Okay, so I'm going to go ahead and change this to, let's look at 65 and up. I'm going to remove that. No, I'm going to do that, 65 and up as well. 65 and up. Okay, so I've got them both set to the same. So here is the population distribution of people 65 and up. And so what I'm looking at in that previous map is just the raw numbers. Okay, so I'm looking at all of the people in California by county. So So if I click here with my ID tool and I scroll down to 65 and up, well, I don't know where that is. There we are. It gives me the raw number, so 146,000 are in there. And that is great if I want to just know the total number of people. Maybe I want to plan a retirement seminar and I want to maximize my trip and I want to talk to the most oldsters that I can find. However, if I want to look at a map that is not being influenced by maybe the total number of people, by the population, I need to do what's called normalizing the data. And if so, for instance, if I'm looking at two different places, this town of Derryville and the town of Midsummer, and I'm looking at the number of murders, I can see that Derryville is a much higher number of murders. But if I look at the population, actually, I don't ever want to go to Midsummer. Their murder is 2%. Their murder percentage is much higher than the town of Derryville. And that's called normalizing. I'm taking the population into the account, into when I do the data analysis. So let's go back to this and let's look at the population of oldsters normalized. So I'm going to go back to properties and I want to normalize this by the total percent of population. No, population 210, sorry. All right. And then I'm going to turn this off. Whoa, totally different. So when I look at this map and I want to understand where the old people are, and old is a relative term, but where the retirees are in the country, I can just say there are more retirees than there are here. But when I want to look at the implication, so how is that affecting your community? How many services do people need? Who's paying taxes? If I look at this, which is normalized, I can see a much different pattern. I can see that the percent of older people in the United States really shows up in the center of the country, and not so much, this really showed up as pretty light green when I didn't normalize the data. If we wanted to look at the density, I'm going to copy this again and add it. If I wanted to look at the density, I could normalize this by the area. So I want to know how many older people per square area. I could look at my map this way, and then I've got a high density area here, so lots of older people per square mile there. I'm going to go back. Where's my blue arrow? Aha. And a lot of old people per square mile here. Okay, so I just had an office hour interruption, so I'm not really sure where I was, but we're going to go ahead and close up. So when you look at density, that's a type of normalization that is comparing the value to the unit area. Percentage is another way of normalizing, so you're looking at the number of children as a percent of the whole population. Things that don't get normalized are data that is already a rate or an average. So if we look at this data layer again, and I think there is median age. These are already normalized, so it's kind of the average age. So you don't normalize an average. Average household size, you don't normalize that. So you could normalize housing units. You could normalize, let me see, the number of renting units by the total number of housing units. You couldn't normalize, let me move this so you can see. You wouldn't normalize the number of owner occupied by the total population. So you need to normalize data by whatever data type it's part of. So I could normalize the number of farms by, I wonder if there's anything per, no, this is farms. So I couldn't normalize that by population. It doesn't tell me how many people are on a farm. I could perhaps normalize the number of crops. Nope, I couldn't even do that. Yeah, there's not much in here I can normalize farms by. So any of the population can be normalized by, so I could normalize age 65 by the total population. I could normalize households by male by the number of households. So you have to normalize it by whatever it's part of. And then the last piece I wanted to talk about is color, and this idea of using color that has meaning. There's a lot of science around color. I like that they completely, I mean, this is cheerful and coward, and so depending on what you want to map, different colors have a lot of value. There's some color preferences that you need to think about when you're making a map, you know, who your audience is. And then there is this great website called Color Brewer that I use all the time, and I'm going to just Google that, maybe. Color Brewer is a site that was created by Cynthia Brewer from Penn State. And, whoops, let's go back to there. And it lets you have, oh, she's updated, gives you some examples. So let's say I want to do a qualitative map. You can see I have a much different color scheme that I can use. I want to consider color blindness, and maybe I want 6 classes of data. Ooh, nope, nothing's going to work for that. For 5? Wow. 4? Okay, so if I've got color blindness, I could pick just a few options here. I love this. Now let's say I want to think about adding roads, and gives me some different options for just looking what my how my map would look. And then it also tells me what are the color values that I'm using. And this becomes really helpful when I'm back in ArcGIS, because I can set my colors in ArcGIS to match these color symbols. So often what I'll do is with Jing, I will copy my color selection. So let's say I really want to use that, and I will make a palette for myself on a Word doc that helps kind of document what my colors are. So I'm going to go ahead and put that on a Word doc. So if I find a color scheme I like in Color Brewer, and I chose the RGB color numbers, I can make a copy of that, and then in Properties, I can wait and wait and wait. Okay. Okay, I can take my Color Brewer and actually under More Colors I can set that to RGB, and then I can set my colors to match the color scheme. Oh, I'm going to move this over here. Really, that is really ugly actually. Okay, so I'm going to go ahead. This is not a great example because I've got more colors than I need. Turn that to RGB. So 166, 206, and 227. So 166 and 227. Okay, so I can set my colors that way using Color Brewer and know that my map kind of meets some researched needs. I can also go to sequential, so that's what they're talking about for a Choropleth map. Let's say I want 7 categories and I want to go with the orange. It gives me these orange options to try. I can also just copy that and use that. It lets me change my roads and try different colors of roads with that. So it's a nice way to play around with colors and ideas to make a good quality map.